All right, let's add our linear regression tab to our stat tools. I'm going to pull that in. And we're going to add linear regression to the set of tabs. H underscore linear regression. Add a tab to the main spreadsheet, to the main application. Linear regression. Okay. Let's spin up the application. Stringlet run app.py. So we've just added the linear regression tab. Let's take a look at it. Linear regression, we're going to use the bivariate. When we do linear regression, you need a quantitative variable versus another quantitative variable. So we will use height and weight, compare them to each other. So linear regression, we'll put height on the x-axis, weight on the y-axis. We can slim it down by subgroups if we wish. Yeah, let's look at gender and let's go males. So the males, there's 46 of them. Average height, average weight, standard deviation of height, standard deviation in weight. We get an R value, R squared, the intercept, the slope, and we can run a test here in a second. But this is what the scatter plot looks like. We can also do the QQ plot of just the residuals, the difference between the point and the predicted line here. And that's what the QQ plot, ooh, I should change this to be that other QQ plot that we've been using on the other pages. Yeah, I'm going to change this. Not today though. I'll change it for the next, later. And then we can do a hypothesis test versus what do you think the slope is, the confidence interval for the slope, the prediction interval for some value of x. If I, let's see, if the x's are the height and y's are the weight. So let's say I took a height of a guy and we say he's, I don't know, 65 inches. Then I predict that his weight is somewhere between 114 and 215. 95% sure of that. Now the confidence interval for the average height, not just the straight up height of a guy that is 65, but if I took the average of all guys that are 65 inches tall, what's my 95% confidence interval for where the average weight is? The average weight somewhere between 152 and 176. Now the slope for height and weight, right here we have slope is 2.2 pounds per inch. We're 95% confident that the slope pounds per inch is going to be somewhere between 2.8 and 5 pounds per inch. And that is the end of the linear regression. Let's take a look at the code that's involved. So the linear regression code, we pull in all of our libraries that we're going to use. One big function. We have linear regression title. We break it up into 2 columns. Grab the Google spreadsheet, the bivariate tab. Let's see, numeric, non-numeric columns like we always do. Let's see, and then we're selecting what do we want in the x-axis, what do we want in the y-axis, and then we can do a category variable to do some subgroup of the entire data set, like we did gender males. That's what we did here. If the category is set to none, then it's going to be everybody together. We're going to bump in the entire data frame, and that's if it's not none. Then we break it down into which category we picked. If it is none, then it's just everybody. And this is a little warning that if your x variable and your y variable are the same thing, you're going to get a warning. Like if I wanted to do height against height, select different x-axis and y-axis, because that's silly to do compare height with height. So that's that warning that we got. I'm going to switch this back to weight. Let's see. If the x variable doesn't equal the y variable, then give us a description of the data set. And slope and intercept, the r value, the p, and the standard error for linear regression. You put the 2 variables in, it grabs all of those things out. To get the predicted y, you take the intercept plus the slope times the x variable. To get the residuals, you take the y values minus the predicted y value. That gives you the residuals. And then the residual squared, that's 2 stars and a 2. And then we can get the entire data frame and then write it out. And there's our data frame right here. This will make dotted line all the way across this bar right here. That's how you create a bar, is marked down with this. That creates that bar. Then we break it up into 2 columns. In the left column, I have that option. 2 different types of graph. I can do a scatter plot or a QQ plot. If it's a scatter plot, we'll plot that. If it's a QQ plot, we'll do this. Yeah, that's what I need to change. I was using that other QQ plot from Penguin library. So I'm going to come in here and change that. And then in the second column, if the x variable doesn't equal the y variable, then we can do the predicted values. Well, we can do all 3 of these things. Confidence interval for what the slope is, confidence interval for a given height, and a confidence interval for a given average height, and a given, what's the confidence interval for the predicted average weight. And so that is all of the things for linear regression. And we'll stop that video. Let's upload our stuff. So let's upload those back to GitHub. The reason I'm loading them back up into GitHub is because eventually when we have one more tab, and after that I'm going to show you how to post the whole project online so everybody can have access to it. And it grabs it from GitHub. So I need to keep all my updates that I'm doing and post them back up to GitHub. So commit the changes, sync the changes, and we are all up to date back into GitHub. One more tab, and then show you how to post your project online.